And we are live. Let's see. Can they hear us? Do we have the right audio? Is the right speaker system set up? No, it's not. I'm glad we checked that. Okay, so this is wireless. Okay, now, can anybody hear us? Marco, Polo? Cameras are okay. All right, you should be hearing both of us. Is that true? Say something.
Hello.
Hello, hello. Oh, where's the old chat here? What's up, everybody? Comments, feedback, whatever. Okay, we are live. Good to see you, my friend.
Likewise.
It's been a hot minute. We saw each other in Belgium.
Yeah.
Just a few minutes ago. We are in. Let me see that lighting. Maybe I can. There. Well, you're okay. I'm just wanna. Yeah, there you go. We are in Krakow, Poland. How do you pronounce it correctly?
Quite well. I mean, if you say it in Polish, it's Kraków.
Kraków. I'm sorry.
Yeah, but Krakow sounds great.
Nope, that's not right. And then you are?
My name is Dariusz, and if you want to say my full name, it's going to be more difficult than Krakow.
Okay, yes. How do I do it?
Dariusz Jędrzejczyk.
Ah.
Yeah.
Wait, okay. Dariusz
Jędrzejczyk.
Jędrzejczyk.
Excellent.
Oh, it'll take a few years. You remember? I have the worst. I have the worst track record with Polish last names. Okay, it took years for me to learn Marcin's last name.
Oh, Marcin is even better than mine. Yeah.
And then now he's gone, so it's all for. And he's still alive. He's just
there
working somewhere else. I miss him, but
me too. Yeah.
But I'm very sad. We don't get to. Well, I mean, I can if we still co-present, then I can still use my knowledge of his last name. I think I almost have it. If it Gojeshak, something like that.
Amazing,
right? Like Now, if you've ever seen his last name, it's an unpronounceable string of consonants, and then there's a sad emoji, a sad face emoji at the end of it, right? Just one heck of a name. Yours is as well, so I'll learn yours, but it'll take years. I'm so sorry.
That's okay. That's okay.
It's not because of you. It's very small, very small brain. Smooth. When did you join the team?
So I joined a bit more than 3 years ago.
It shouldn't take that long. Well, okay. So 3 years ago, that was during the pandemic, I guess.
No, it was already past the time.
2022.
2022. Yes.
Yeah.
So that was in June that I joined, and I am working on the Project Reactor team.
Oh, I know, and the MCP stuff, right?
Yes. So I'm working with the Spring AI folks, and I'm helping out with the reactive stuff. But we also started the project with Christian Solov, the Java SDK for MCP,
right.
and that is integrated into Spring AI.
So let's talk about the reactive stuff first, because I'm a huge fan of that stuff, as well as the AI stuff. We'll get to that. But first of all, what's your story? We're in beautiful Poland. I love Poland. Poland has, it's the best mix of money for fun. You know what I'm saying? It's
we
great.
have a lot of tourists coming to Krakow.
Yeah,
because of that reason.
Well, so I've been to Warsaw. I've been to Łódź. I've been to a few other smaller cities. But Krakow still looks like an old city. It wasn't destroyed in the war, I guess.
Yes,
right?
Definitely. Krakow is amazing. Warsaw has been rebuilt, so it has its spots, really beautiful ones. But yeah, Krakow has the authenticity that you kind of can experience only here.
It is. I mean, it is such a charming little city, and it's the first city in Poland I ever visited. And so we in America we pay Disney to go to their theme parks to get something that looks even 1,000th as nice as this. Gorgeous. So anyway, we're near the city square here, and if you go there, it's one of the biggest squares I can think of in Europe, right?
It's one of the biggest. Yeah. We actually have a bigger one in a very small town in Poland that has a huge market square. I don't know
what's the name of the town.
I don't know. I don't remember. But when you go on a tour here, they will tell you that this is not the biggest one, which is funny.
That's amazing. It is quite something. So anyway, we're in Poland. In Poland, I've met. I mean, we've got several people on the Spring team from here, right? And we've just incredible group of. There's a lot of engineering I think they like. Is it true that a lot of people here work here for other countries in Europe? A lot of IT knowledge.
Like Krakow, for instance, is quite technology centered city. There's a few university around here.
Yeah.
Like there's technical universities. There's also the Jagiellonian University, which I am an alumni of, and a lot of computer science students are around here, but also engineering, all sorts.
Yeah.
So there's a lot of companies that are based here, but also people work for other companies outside remotely, and it's a great place to be. Like there's a lot of meetups and the conferences as well. Have you been to GeekOn or DevOps, which are the biggest ones
and
here?
33rd Degree, and there's one that starts with IT something, and then I've been to like 10 different conferences.
Awesome.
10 different. Some of them got bought or turned into other ones. Like 33rd Degree is now DevOps Poland, and GeekOn is still here.
Mm-hmm.
Oh yeah, I mean, I've been to like so many, and this is a huge community. There's multiple huge Java conferences every year, right?
Definitely.
Most of them I think are here, actually, come to think of it, in Krakow.
That's right.
So that's an amazing thing. Remember, in San Francisco, there's not, right? Like, so what I'm trying to say is I think you'd have an easier time finding a really great Java programmer here in Krakow than you would in San Francisco. Like it's an amazing place here. And so and some of my favorite memories are actually here in Poland.
Oh, really?
I met Dr. Heinz Kabutz, the Java specialists newsletter guy, the training guy, the legend, the Java champion, like one of the very first Java champions, I think.
I also had the honor to meet him, but I think it was in Warsaw.
Oh man, I met him here. We went to the salt mine.
Oh, Wieliczka salt mine.
I don't think people understand. When I think of a mine, I think of like a small cave, and people have a cart and they go in and they have to wash their head. This is not the case here, right? This mine is further down than any of your buildings that are up.
I'm glad you went for the tour, because it's like a really amazing place to go.
Oh.
Like kids go on tours from school, and people like from all around the country come here. It has this like magnificent hall that
if you dropped from the top of the hall of the cave to the bottom, you would be dead before you landed. It is such a huge height. It is so huge. I mean, God, I couldn't believe there's this. You could put a city down there,
Yeah, but at the time this was the gold
Yeah.
of these times. So everyone who had salt, and we had plenty, were doing quite well.
What a place. So we went there. He and his son, who was a little boy back then, is now an adult in college, or maybe even done with college now. This is many years ago. Anyway, Poland, great place, and this is the belly of pierogi.
Pierogies, of course.
Of course. So then, what you met Dr. Kabutz as well, huh?
Yeah, I was at a training of his, actually.
Oh my goodness!
Yeah, excellent. It was performance and kind of how to diagnose different problems when you have issues. So like GCs and JIT and stuff like that.
So good.
And, very useful. Very useful. I really enjoyed that.
Again, this is why I just love how close you are, because this is Europe. This is obviously Europe. You could pay a lot more money for a worse experience in so many other countries, but you come here and you get, it's just wonderful. I love this place. So you went, Dr. Kabutz, you went to the technical university here, and
actually no, not the technical university. This is like the
what did you study?
I studied computer science, but it was not the technical university of in Krakow, but it was the like humanistic, where people study psychology and literature. There's also computer science there, so I didn't have any like physics, electronics,
right?
Nothing like that.
No, but that's okay. Some of the smartest people I know had their university degrees in something unrelated. Are the founder of Spring, Rod Johnson. His PhD, he's a doctor, Dr. Rod Johnson. His PhD is in music.
Oh my!
Right? Yeah, like, anyway, that's really cool. Good for you.
That's amazing.
So then why did you go into computer science? Why not become a plumber or an artist or a poet? What's your
That's
story?
a great question. I mean, come to think of it, I wanted to do something with AI at the time. I was really fascinated with...
When is this, by the way? Like 20 years ago?
So I went to university in 2006.
Mm-hmm.
And those were like full Masters of Science degree for 5 years.
Mm-hmm.
And
okay, for masters. Yeah.
Yeah, we had a different system back then. So now it's in the whole Europe, it's like 3 years and then plus 2 years to do the masters.
Right.
Now then you kind of did the whole thing in one go.
Right.
And I was fascinated by the movie Matrix at the time, and I was like, how would that be even possible? And I was really wondering, what do you do? And at the time I hated programming. Like they taught me programming at high school, and I was like, this is really boring. And I did hope that I can get through computer science studies without doing much programming, but then I found out the case is different. But after a while I started to enjoy it a lot. It became like once you get to know something, you might start to like it. Like in the beginning I didn't enjoy a lot of things, including programming, and I was like trying to get away from it.
Yeah.
So
because did you think it was all the fast moving consoles of the Matrix, or
no, not really. I was really keen to find out how can machines think, what are the things that they could do possibly, and like philosophically, how is that even possible to come up with something? So like this whole subject of what's the term,
cognition.
So there's like this term that combines all the aspects of human knowledge and understanding. That's like cognitive studies, I think it's called.
Cognitive sciences.
So
maybe.
So it's kind of psychology combined with mathematics and study of the chemical reactions in the brain. And so
isn't that
out of that, the neural networks were born, like trying to simulate the neuron and so on. So I got to know a bit of that, but then by the time I already got bored with the concept of AI, and I was more into programming during my studies. So.
Well, I mean, programming is super important in that, but also that I have made the mistake of, I have made, in my misunderstanding, I have made the mistake of saying that AI is not very special because it's just fancy autocomplete. Right. And then I got a good revision on the topic, and you talked about how the brain works and psychology and bioinformatics and these kinds of things, and neural nets. And like somebody explained it to me, and maybe you could correct me on this, that basically you've got neurons in the brain that fire when they have clusters of neurons that fire when something has to happen. So if I show you a phone, certain parts of the brain fire, they ping, they make a sound that's how the brain identifies the concept of a phone. But if I show you a computer, which is kind of like a phone but it's not exactly, then a similar but not related, but a related but not exactly the same set of neurons will fire.
Mm-hmm. I'm by no means an expert in that area, but it's all very fascinating to me. Like,
but they did the same thing with the neural net.
Mm-hmm.
The neural net is basically just a set of neurons, and they taught them to fire when certain things happen.
I think there's a lot of
and it's actually the same result in a lot of cases. I guess I'm trying to say.
I see. I think it's just a model, right? Because in real life, in living organisms, there's a lot going on. It's not just electric signals. It's like the influence of the substances that like are hormones and things like that.
But even that, emotion and hormones and all that, at the end of the day, that just registers as things that fire in response to certain signals. And so, even if let's say that you were stabbed or something terrible like this, right? And then I hold a knife, and it makes you go, "Oh God!" That is itself an emotion, which in turn is just the representation of certain neurons that have been firing. And so if you can do the same trick, if you can train this neural net, flood it with all these different inputs, and then from a few certain inputs, have it sort of reverse engineer what the other input should be.
I guess the biggest difference is that we train those machine learning models once, and then they kind of don't continue learning. And we humans continuously change the way we react to different signals. Like you would never react the same way to the same signal, because you change the environment all the time. You get different signals, and that changes. So maybe one day we'll have like those LLMs or other tools that we use that constantly learn. But now we have those, iterative processes that you get a new model in a few months that's upgraded with some knowledge, but it's kind of not constantly updating itself.
But anyway, it's actually a lot more interesting than I thought. I don't know if it's because you're right. Maybe the last frontier, maybe the last thing between a true AGI and what we have is the ability to improve, and to iterate. But still, pretty good. I mean, pretty good. Like, I didn't know it was that sophisticated. That's amazing.
It's super complicated, actually. The subject is so broad. Like, the human cognition is not just linguistic. It's solving a lot of problems, and AI as a term is now used just for the deep learning models that we now have to generate text or audio. But like, there's the subjects of planning, there's reinforcement learning, which are all in use to train LLMs right now. So it's quite interesting, but at the same time very broad, and we can think of all these different applications that have their own specialized means to be applied and understood separately.
Full self-driving cars are using neural nets.
Exactly.
That's amazing too. So you were in university and you learned about you went in there trying to rebuild the Matrix. And by the way, that was a great movie. I mean,
I was really keen into those.
Were you? I mean, I was keen into this sudden, because you know what else? You know who else did it? I don't like Steve Jobs. Not much of a fan. To be honest with you, but he did occasionally say some very interesting things. And one of the things he said was that this whole something, I'm paraphrasing, okay? I don't remember the quote, but he said something. He said basically, the whole world is just built by people who are not smarter than you, right? Like, you might feel like a small person inside of a giant thing, but it was just built by other people just like you, who wake up and they scratch their head and have coffee and go to work, and like the whole thing, everything we see around us, every building, every government, every computer, every rocket, everything in space, everything was just built by regular people. When you think about it like that, it's like, oh wow, you really, if you wanted to, you could do anything. There's nothing that anybody else has done, that anybody else who's ever done anything, they were just human like you. They had less advantages than you do today. As he didn't say all this part, but I extrapolated, right? Which is like, here we are with modern technology and modern healthcare and modern lifespans. We could do more than the most impressive people we know from the past.
Yeah, it's like there's those quotes like, standing on the shoulders of giants. That's one.
Totally.
And the other one was, which I really enjoy, is stay hungry, stay foolish. So that's a kind of just keep on learning. Like, that's the motto that can take you really far.
Right. And so when the Matrix came out, and they basically said, like, this whole world of ours is a construct. In this case, they're talking about, like, these crazy cyborgs or whatever, these computers. But the idea that it can all be torn down or rebuilt by anybody who's willing to, see past what seems as imperceptibly, insurmountably, like, pervasive. I don't, what I'm saying? Like, it's very easy to think you can't change it because it's just the way it's always been, and it's just not true, right? You can change anything if you want, right? Like, and that's if you go into a large company and they're just doing things poorly as a software team,
it takes courage, I guess.
And also a willingness to say, hey, you're not more special. I mean, none of this is like a universal constant.
I guess like 2 weeks ago we had the Nobel Prizes granted to a lot of very smart people who were courageous to actually undermine the status quo and bring something new to the world.
There you go. It happens all the time, and you could do this too, and you don't have to change the world. You could just start with your team, just remember, just because you have a terrible practice doesn't mean you always have to have a terrible practice, Start small.
My favorite Nobel Prize winner is Richard Feynman.
Yeah.
I guess a lot of people admire him, but he was, if you read his autobiography books, he gives like his perspective on things, and I find it really amazing. Like, he was very humble in his approach, and he was just like, okay, let me just see it from the little tiny parts, looking from first principles. And he never kind of considered him a genius. He was just like, I am trying to understand this, that's all. And out of that came really exciting things, like in quantum theory, and things that are now very influential to the way that people understand particles and waves and things like that. So very smart guy. If you want to change the world, just look from his perspective.
Yeah.
I guess it's amazing.
Well, but also, yes, I agree. And then also sometimes really smart people do amazing things like you by watching TV or movies. And I was reading apparently, so the concept of the warp drive in Star Trek.
I haven't seen that.
Have you never seen Star Trek?
No, never.
Okay, well, in Star Trek they have these ships that travel around the universe, but of course the universe is enormous, and so they use something they have in order to go from one part of the galaxy to the other with any speed. You have to be able to travel faster than light, and of course it's not possible. Or at least we don't know how to travel faster than light. But there is somebody who, basically there is a way to do it. There is a theoretical possibility by using something called negative energy, where you could warp space-time, just like the sun sitting on top of the tapestry of the universe warps the tapestry and creates it dilates the space. Just like that's possible. If in theory, if you could add something called negative energy into the mix, you could actually move an object through space-time faster than light, right? And this is set up, and he did it based on Star Trek from the 60s, and that set up a whole chain of scientists who are actually looking at this stuff. And there's now the solution that he had was theoretically possible, but impossible because it required a vast sum of an energy type that doesn't exist, or at least that we don't know about yet. We don't know how to find it,
That makes sense.
Right? And it requires like more than the sun, worth of energy, which, that it may as well be impossible, right? So he started from that, and there's a whole string of scientists that have gone from this one person's hypothetical paper over the last 30 years, and now they have it to the point where, it's not there yet, but maybe in the next 50 years they could get it there, and it could be something that human beings could use, and we could do it with everything is within the realm of possibility again, and it wouldn't be faster than light, but it would be like so fast that it would be very good. It wouldn't be faster than light, but it would be fast enough that it would be useful or interesting. And I just think you never know where sparks of genius are going to come, but
yeah, like sci-fi is a great inspiration for a lot of people. Even if it doesn't make sense to people who really understand the science, it still kind of makes you wonder and ask the questions, right?
Yeah. So anyway, we did all that setup, and I'm really glad because so then you went from university. What did you start doing? Were you doing Java programming when you went to university, or C, or what?
Also, they taught us all different things. Like I started with Pascal.
Oh, nice.
And then we moved to C/C++, how they called it. So it was just algorithms and stuff, and then more languages. And I guess Java was the one that prevailed in my life out of all of those experiences with many things, including Scheme, which was quite interesting, or Prolog.
Right.
I actually had to learn Prolog, which was quite fascinating, but impractical for me today.
Sure.
But as I said, I didn't really enjoy programming that much.
All these languages and you didn't even like it.
And the thing is, I really wanted to do something that you can kind of see from sitting in front of the computer. How do you actually experience the program, not just clicking on some web interface? I was like, oh my gosh. And a friend told me, hey, there's an ad about a job in game development.
Yes.
And I was like, oh my God, I really want to make games. Like games.
Do you play games?
No, there's a lot of interesting things that I do, things that I don't then use, but
okay.
I didn't play games that much. I was into games when I was a teenager, and then I stopped because I was too involved.
Okay.
But I do enjoy games from the perspective of like this is a really creative process.
Right.
You kind of can shape this mini world, right? This is a model of the world that you can do amazing things that you cannot do in real life. So this is exciting,
and
as a creative thing.
So was that your first? Is that the first time you liked the idea of programming?
That's where I started to enjoy programming.
My theory. Here's my theory. I think most programmers that have ever gotten into software programming, my theory, and again, it's just anecdotal, so it's not even really a theory, but everybody I've ever met who's ever become anything, they started, including myself, although I'm not really, good or anything, but anybody who I've ever met who's ever done anything, they start because they want to see the pixels on the screen dance.
Exactly.
Right. Nobody wakes up as a kid and says, I want to write a COBOL mainframe job. That's not exciting. You can't understand why that works or what it does or how it works. But if you can make something move on the screen, animation, games, true. Whatever. Yeah. Go on.
Yeah. So it's like a tool that you can use to make something work. And I enjoyed like programming from the perspective of writing some code to achieve an algorithm. I enjoyed that when I was on my second year of my degree, and we did like a lot of exercises like this graph search thing and stuff like that. And I enjoyed the endless nights trying to submit the solution to an algorithm problem, but like software engineering. So from the perspective of like patterns and using the right modeling techniques to get something that was super boring to me, and I really wanted to see something on the screen, just like you said. And I got into game like mobile game development. That was my first job, and that was in Java, which is interesting.
Android
for the iPhone.
Oh, for the iPhone.
That's funny because we had like I joined the studio that did games for those old phones, like the small mobiles, Nokia phones,
like Trio and Palm and.
Actually, those were the commodity phones that you had, like Nokia 3310 and stuff like that, and then you could play games on those. And they had an engine that they wanted to use to run a game on the new iPhone. Like this was the new thing,
right? Like a Unity for games. On the
so
phone.
there was like this transpilation, cross-compilation engine that we used, and we built for the iPhone using Java, which was an interesting experience.
Cool, yeah, actually.
Yeah, and the game was so much fun. It was called Icy Tower. It was a remake of a game that was quite popular before. Have you ever played Icy Tower? Have you heard about it?
No.
Like, there's a lot of fans of Icy Tower. It's kind of this game that you have a character jumping on platforms, and you go and bounce off the walls, and you go faster and faster.
Sounds fun.
It is fun, and on the phone it can get even more fun. So we did that, and I got involved in the physics engine. I said I didn't study physics, but this was like elementary grade physics, just acceleration and velocity, and that was really interesting and fun. And then we kind of developed different kinds of game modes and stuff like that, until it got boring when we started to get involved in animating the different publishers' logos and stuff like that. Yeah, but creating a game is amazing.
You got to do it once. Everybody's got to try it once.
Yeah.
This I'm kind of like you. You said when I was the last console before 2018, I hadn't played games. Since the 90s. No, like 80s, late 80s, the regular Nintendo Entertainment System. And then, either we didn't have access to one or I was too busy. I was too poor or too busy. Either way, I didn't have games until 2018.
I see.
So there's a whole, almost 30-year gap where I don't know anything. I have no idea. Anyway.
What got you hooked in again in 2018? Which game was it?
Well, it was 2018, I'd been on the spring team for 8 years, and we IPO'd. Remember Pivotal IPO'd? And I made a little bit of money, not a lot, just enough. And I thought, maybe I'm not going to die starving on the streets, Maybe I will have a career. Maybe it'll be okay. I don't know. I finally let myself think I could relax a little bit. And so I said, okay, I'm going to go buy a Game Boy, right? So I can travel on the airplanes with the Game Boy,
A Game Boy.
But the problem is they don't make Game Boys anymore.
Yes.
And so I said, I went to the Best Buy and I said, "You boy, sell me your latest Game Boy." And they looked at me like I was, crazy. And they said, "We have this thing called the Switch."
Mm-hmm.
And so they sold me one of those, and I went to the airport and I downloaded some games in the lounge because I was on the way to there. I flew in, did some laundry basically, and then flew out. Right, and I had only time enough to go to the Best Buy and do some laundry basically in San Francisco. And so I went and I got this Switch and I downloaded the usual video game. I downloaded Mario Brothers because I thought, well, that's going to be huge, right? And because that was like the thing I remember from 30 years ago, right? And then I downloaded Zelda Breath of the Wild. Right?
That was a game.
Did you play that one?
I remember seeing Zelda once.
Yeah.
I think I played it at someone's computer. It was a fun, kind of very green animated thing.
Beautiful.
Very, very, yeah. The images were very, very nicely.
It wasn't even the most amazing graphics, but it was just this incredibly immersive. You could spend days wandering around this game and never see everything.
Mm-hmm.
Everything you could see, you could go to and explore.
Oh, that's great.
And it was a huge world. You could just do whatever you wanted. You could go for hours and not do anything useful. You could just climb rocks and mountains, whatever. It was very. So if you're like me and you're spending, how much did I do? I did like almost 2 months of my year was off the ground on planes, right? I spent 2 months of my life 30,000 feet or higher, and so that meant I spent most of my year on planes for many, many years in a row. And so this little Switch was with me in my backpack ever since, and anyway, it's nice to be back in games. I was like you. I was like, I should avoid this, and you were right and I was right. We should probably avoid them there.
Oh, there's place for that.
They're a distraction, but they're very fun.
I think the games, if you choose wisely, can teach you stuff. Like I've met our colleagues at Devox, and they recommended some things to me that I should really try with my kids.
Yeah,
there are games that teach you strategy and thinking, and those can be very useful. They don't waste time. It actually
they build skills.
Yeah, and also like when I was a kid, I actually when I was a teenager, I played things like Baldur's Gate.
I've heard of it. Wait, isn't that a new game? I thought that was new.
There is a new one.
Oh, there is.
It no longer has this isomorphic view. It has like this first-person perspective, or like from the back, I think. But those were the times that the role-playing games were like, from a far distance, looking at the whole scene, and you could pause the game and like plan what you want to do, but it kind of has this really interesting story behind it, and you can choose a lot of things that you want to do, and you explore the world. I really enjoyed that, and
cool.
It teaches like that there's different characters, that you can team up with people that are more like you, and that you will have conflicts with others. So yeah, a lot of fun in those.
See, this is the guy. I should download Icy Tower and Baldur's Gate when we're done with this episode. Okay, so that's super cool. That kind, I love that kind of backstory. It's very good to know that people go through that same journey, And then you were doing games. What did you do after that?
So I quit the gaming studio and I joined a Java shop that was doing things in enterprise Java, and I was like, all right, let's learn this stuff. But I started to enjoying because I already had some engineering experience building things that actually need to kind of last, and other people need to work on it, not just myself. So I got that elementary knowledge of how to create things that can be sustainable for some time at least. And I started to enjoy the enterprise patterns and things like that. And that's when
So you were learning one of the most valuable lessons of all, which is building something is easy. Building something that endures is hard, right?
That's
actually
true.
where
that's true.
The difference between a junior programmer and a very senior one is they can do the second thing,
And that can actually be quite rewarding when you see that the things that you build are used and last, and you can evolve them and so on. That's what Spring is about, mostly.
100%. Yeah, it's like helping you solving the problem, but also solving it elegantly so that it's something you want to work on again. Because that's the long tail of cost of software development is, of course, maintenance, right? So that has to be paid down immediately, and we help you with that. So okay, so then you did enterprise Java. Were you doing Java EE and Spring, or is it like just?
So I started a bit like there was some templating engine. I don't remember the name, but people
Timely,
from
Velocity, FreeMarker.
Velocity.
Yeah, that's a nice one. Apache
Yes.
Velocity.
And then there's an exciting project came up since I had some mobile experience. An Android thing came up to be, and I learned Java 5 kind of flavor.
Yeah,
it was much better than coding back the game for the iPhone in Java 1.4, where you didn't have like those collections and stuff. And we actually had some recommendations back then not to use objects and things like that, just primitives all the way as arguments.
Oh dear.
Because of the cross compilation issues with maintaining reference. So crazy stuff. But so I learned a bit about mobile programming, like the concepts there. I really enjoyed Android, the whole kind of view that's holistic towards the way you structure the view and the way that you can launch actions in the back. It was a whole new realm for me that I learned from the ground, and I really enjoyed that. And after that job, that was my last year of my studies when I was working that job, and I quit just before finishing my studies to focus on the thesis and defending that. And once I did, I got invited to go to Spain.
And what was in Spain?
And I joined a social network in Spain called 20, and 20 was like this kind of Facebook clone kind of thing that teenagers used. And that was really funny that the Spanish market at the time was completely different from the rest of the world, where Blackberries were the things that business people used. In Spain, a Blackberry was a phone of a teenager. So I joined the team that was doing Blackberry and J2ME.
Oh, nice. J2ME. Heck yeah.
Yeah. Applications for the social network. So yeah, quite interesting.
Wow. And so okay, interesting. Did you live in Spain then for a little while?
Yeah, for almost 2 years. I actually learned that not every mobile platform is as nice as Android.
No.
I was so shocked.
No. J2ME came before Android, and when Android came out, I didn't see any reason to ever use it. Did you use one of the J2ME? Did you have to do the like only integers, and only some of them didn't even have floating point numbers? Some of them had, you couldn't even rely on collections. There's like subsets that would make you cry if you had to think about how to program in them.
Yeah, I think I spent most of the time at the BlackBerry side of things, and there we had some capabilities that we could use. I remember the floating point thing was an issue in the gaming thing.
Yeah.
So I had to learn that there's this pattern of like fixed point mathematical engine, mathematical library that you can use. Quite useful, actually. It's good to know these things and optimize so well. But yeah, after a while they killed J2ME, they killed BlackBerry, so I moved to the PHP world.
Okay, security, get this man out of here. I don't know what's happening here. PHP, what happened there? Why?
That's fascinating. At the time, there was this architectural pattern called LAMP, right?
Yeah.
And PHP was the
Linux,
thing
Apache,
that ran
MySQL.
Facebook, but it also ran other places around the world. And they were building like this horizontally scaled monolithic application that I was helping the mobile application developers to connect to the API. Mm-hmm. And I spent some time in the framework team as well, kind of working on the queuing things, so you could like add tasks to a queue, memcached, things like that. And I found that to be super interesting.
Yeah,
that's when I got to backend development. I was like hooked in for a lifetime.
Good. Okay. Well, so did you very quickly move on and away from PHP, or are you going to tell me?
I did. I did. Although at the time I was more fascinated by the architecture and the capabilities like of thinking differently, not just like processing things in the database, but like offloading that to the machines that run the programs. Like those were all the things that
Back
I was
office
so
processing.
fascinated with, that you can have so many machines, and I actually saw the servers. It's not just a phone anymore. It's like a whole farm of servers.
Yeah, exactly.
Data center.
So powerful.
Yeah, so very interesting. And I got back to Java finally, moved to London, and I worked at Last.fm.
Okay, yeah, I use them.
Have you ever
Scrabble.
used Last?
Yeah, Scrabbling. Oh, that's so cool. I had no idea. I never quite understood what it did. I did Scrabbling was your own little station, right? Like,
I think it was such a great idea.
tell me what the exact thing that it did was.
So it was just a signal that was sent to their servers that you listened to this thing.
Yeah.
And out of that, you can build amazing things. The team at Last.fm, like Richard Jones was the founder, one of the guys that came up with the idea. And I met him, great guy. And they decided to combine the idea of that you listen to something with the idea of recommending things and listening to things that are similar, right? That's the whole concept.
Right.
And they managed to do amazing things. Like they were pioneers in the music recognition, recommendation systems and stuff like that. I still believe that their algorithm is the best for recommending music. Like if I use Spotify, it's not giving me such great ideas for things to listen to. The algorithm that they use was called collaborative filtering, and they essentially kind of figure out what are the things that people that listen to the thing that you listen to are also listening, and then they run machine learning algorithms to cluster that and give you things to listen to. And a business grew on top of that to, hook into various engines like Spotify and others to play the music for you. So that was the business transformed.
So they're not playing them; they're just it was a set of, that's what it was. It was a set of like plugins.
It was a plugin that just sent the information to the servers, and the servers wrote that to the database, which was super efficient just for scrolling, which is very funny.
Okay, so it wasn't a way to play music. It was a way to get better recommendations about the music I was playing. That's what it was.
That was the whole principle. Recommender systems are fundamentally amazing, useful, and I admire everyone who is.
No, they did a great job. When it worked, when I would find good music there for sure, but I kept feeling like I was missing something, because I was used to I wanted to play music, and that wasn't the full.
But they came to that stage with radio. They had Last.fm radio, so you played the thing like artist radio or like this tracks radio.
Well, that's the other thing. I wanted to just play the thing I wanted to play. Mm-hmm. It was this very sort of. I never quite got it, man. I'm telling you. I tried a lot of times, and I know, is it Ollie? I think like even his status gets updated by this. You can actually have Last.fm update your social status on whatever, on different places.
A huge community grew around the idea of scrobbling, and very huge fans.
Huge. I mean, I remember trying it. Yeah, that's decades ago. That was cool. That was way before I learned about Pandora and Spotify and all that.
So the interesting thing about Last.fm was that they were doing microservices because the term was even coined. Like they had different services for things that were specific, like those recommend, like there was a place that I worked on that system where you were able to see the charts from last week, from last month, like what artists are popular, what tracks are popular, and so on and so on. And that used Hadoop. They were there's this Hadoop book. Do you know the red one with the from O'Reilly with the elephant? And there's a section about use cases of Hadoop, and Last.fm is there, and I was so fascinated. I joined that team, and I learned so much.
Cool.
Yeah.
And they're in London. Are they still around? I don't know.
They are still in London. Cool. They are part of CBS Interactive. That's the company that acquired Last.fm.
Okay, cool. I should try them out again now that I've got an idea of what they're doing. That's cool. And then
then I got into big data. Right, that was the thing. 2014. Around that time, I joined the consultancy company, and I worked on various things, big data, like Apache Storm, you recall that?
Yeah.
So kind of a live running streaming thing, and other things like Apache Hive on top of Hadoop,
Right.
HBase, and we were consulting banks and coming up with architectural ideas for them how to deploy the big data strategy
Right.
onto their existing
warehouses and things like this.
Exactly.
I see.
Yeah, so I learned a lot about big data. I was also teaching courses. I was a trainer of Hadoop, Hive, and also Couchbase, which was in their portfolio.
Right.
And that's where I got into reactive programming the first time.
Because
the Couchbase driver was based around RxJava.
Nitschinger, yeah.
Yeah, I met him once on a call.
So people don't know, when we introduced the reactive stuff in 2017 across the portfolio, by that point, Couchbase already had reactive support in their driver, and the Spring Data Couchbase module was basically, it was very easy to make that official release, and then, Couchbase is great team. Do you know the history of Couchbase? Like,
I'm not sure.
CouchDB and Membase.
There was CouchDB. They combined the efforts. I don't know exactly how that.
It was all very interesting. And then, of course, CouchDB itself came from Katz. What was his first name? Who worked on Geronimo? Was it IBM? Not Geronimo. IBM. The thing that came after Lotus Notes. IBM. It's a workspace thing. After whatever. It's like a really interesting lineage of just really hard problems, and people doing amazing things. Eventually you get CouchDB, which is really nice, but it was I guess that was a document database, and then Membase was the key value. Memcached was the key value thing, and then they merged it, so now you have key values that point to documents.
Yes. It was an interesting architecture, actually. Yeah, it allowed different kinds of optimizations, and also like this whole NoSQL movement and understanding things differently than regular rational databases. Great
Super
to learn
good
stuff.
So then were you working on the Couchbase stuff or what? Or just started to get familiar with it and you really appreciate the reactive stuff?
They were helping customers with Couchbase, and they run a training program. So I learned Couchbase just for the job of teaching people how to use it, which was quite fascinating. But I had some experience developing systems, so I didn't feel as bad as I could learning something from scratch. But I did have to learn the reactive thing.
Right.
And my mind was kind of completely blown off by the new patterns and the weird things that were possible with this, but also quite fascinating how it's built. So I spent quite some time understanding that, because I needed to teach people how to use the RxJava reactive chains.
Right.
They weren't as reactive at the time as.
So that's right. The first version of the driver, the Couchbase driver, was RxJava, and then 2.0 they used Reactor, right?
Did they? I'm not sure.
I think so. They had some sort of switch because they just. Somebody will correct me. It's been a long time, but I remember that's true. That they went with reactive first, RxJava, and then it became more natural to. I'm pretty sure. I'm sure my friend Laurent. Well, maybe he's watching. Maybe he can. Laurent Dogan. He can help me remember. But anyway, I think
I met Laurent. He was at the course that I taught.
Oh yeah.
He was like from Couchbase, kind of seeing how things are going. Yeah.
He and I have done presentations on Spring Data Couchbase together, and
awesome.
Just feeling super fun. Anyway, carry on. So that's cool.
Yeah. So at the time, personal events started happening. We decided to start a family with my now wife, and I moved to Krakow and joined the Polish e-commerce company called Allegro, where I was on the team that did the platform / library kind of enablement for the entire engineering, Spring Boot starters for the whole company, running discovery service using console.
Nice.
central event bus on top of Kafka, which is called Hermes. And it's quite a fascinating. I love architecture.
Yeah, me too.
Fascinating design where like the developers are decoupled from Kafka completely. They just have a UI where they set up topics that they're interested in, and there's a inverted model where you push messages by just hitting an endpoint, a REST endpoint.
Sure.
And you receive messages by exposing a REST endpoint. So that's
kind of like Prometheus does, where it's like it's similar.
Similar, yes, okay. yes. So it's kind of very good for decoupling. Like the applications don't know about Kafka drivers at all. They are just,
and they don't have any long-lived socket connections, so they can scale more naturally as well.
Yeah, I mean,
there's only one place in the whole company that has sockets that are kept, which is the Hermes itself.
Yes. I mean, so there's like the concerns of redundancy and scaling that are completely moved to the wrapper of Kafka.
Okay.
That needs to take care of redelivering those messages, and it's quite an interesting subject. But it is now concentrated on the team that drives this, and microservices developers are kind of free to write software as the business needs, not worry about the infrastructure at all.
If they want to worry about consuming messages, they just have to they can test an HTTP endpoint, right?
Exactly.
The callback flow for that is very natural. Oh, that's super cool. Okay. That's really nice.
I learned so much at that time because I actually entered the on-call schedule the first time in my life.
Hey, if you've done that, you should. If you haven't done it, you should. At least one time in your life, wear a pager or whatever the equivalent is today,
a phone. I did that, and I was the first nights were really crazy for me. I got a call about some disk running out, and I was, oh my god, what is this about? But as time went, I learned all these things that are taught in the Google's SRE book.
Right.
So how do you actually perform the steps when things happen? You don't try to understand the problem, but just roll back or deploy something that works and so on. Really fascinating things. I had the pleasure to learn and work on at the time. And as I grew in the role, I got more experience with even more infrastructural things.
Yeah.
Like, one interesting project that I did was in Puppet.
Okay, yeah.
So that's Ruby, right?
Yeah.
It has a flavor of Ruby. So we needed to deploy these console nodes. So you have like the service discovery on top of console is that you have an agent and a central broker system that they kind of dispatch the updates to, and they need to synchronize. But it's kind of the single point of failure in your infrastructure if that's the knowledge about
the agent or the
console itself. Like if you don't have an agent that tells you where the services that you want to talk to are, what their IPs are, then if that breaks, then you kind of cannot communicate. So that's really critical to have that running. And suddenly we figured out when the scale grew that when you deploy a change to console configuration, it brings down all of the consoles in a very short time window. So we wrote a server that would synchronize those things to kind of wait for each other using a lock that was centralized in Zookeeper, by the way.
So you've got another centralized configuration server? Oh my goodness.
Because Puppet just didn't have that capability to kind of perform a rolling upgrade on VMs. There was a more recent kind of Kubernetes-like deployment for the modern services, like when you had a microservice, you deployed that on Mesos.
Okay.
So Mesos had this
rolling out all the classics here,
had this scheduling system orchestrator called Marathon, and it was managed, and we had a very nice environment. But for us, the platform guys, we didn't have that beauty. We had VMs, so that's where we kind of had those critical services, and unfortunately, Puppet didn't have that beautiful rolling upgrade as Mesos did.
Oh dear.
So it deployed everything like within a 30-minute window, and like things could crash. So we needed to coordinate that somehow. We came up with a nice idea, and it worked. So I got to learn more, like lower and lower levels of the architecture.
It's all processes all the way down.
Mm.
Doesn't matter how high you up in the stack you are.
So
That's
having a bit of that, I kind of got more comfortable with this area, and we worked on something that you call a service mesh architecture.
Yeah.
So another agent that would be deployed on each node together with the app.
Is this Istio or?
So we couldn't use Istio because Istio had the requirement of Kubernetes, which we didn't have at the time.
Using Mesos, yeah.
So I mean, the control plane of Istio needed to be deployed in Kubernetes, and we had like this planned but not ready. So we needed to come up with solutions, and we used Envoy, which is the
Envoy, the Yahoo or whatever it was. I think.
Sorry,
was it Yahoo? Who created Envoy?
Envoy was actually created by. My gosh, I don't remember the name of the author. I'm sorry.
Yeah, no problem.
But it was not Uber, but this other company in the States that
Lyft.
Lyft. Yeah,
right.
So it was created at Lyft.
Yeah.
And oh my gosh, I wish I remembered the name of the author, but he gave the word out and went to companies that got involved. Google dedicated some engineers to help out and bring the code base to a very good standard and so on. And so Envoy is a really high quality C++ project, which has now some Rust in it, I suppose. But we had to learn a bit C++ when when trying to debug Envoy, and we also had Lua scripts to do things.
Oh dear!
So it also has that kind of capability where you kind of can dynamically configure access to different services. But it was a fascinating work that we did with a team of amazing people.
Wow!
So now it's running in production, and we actually shipped the control plane on Java,
right?
Which is not a regular thing because people that work with the Envoy control plane, they use the Go variant, and we were at mostly Java shop,
right.
so we used the Java control plane at the time,
and it worked.
It worked. We built it with Kotlin actually.
That's cool.
Yeah, so
super cool. Okay, well that is like, so it sounds like you did a whole bunch of good stuff, like interesting stuff. You went from mobile to backend to,
I was very fortunate to have that kind of experience.
Micro to the macro and everything in between. That's the kind of experience that I think makes a good engineer. So what did you? I mean, you didn't stay at that company, obviously, or
that was the longest I stayed with the company. Yeah, I at some point I was a team lead for 2 years. And then I figured that's not the thing I want to do at the time. COVID started, and in COVID, staying at home with my little one, who was just born 2 months before COVID started, it was a bit. It had its toll on me for quite some time, staying at home and managing a team. And I decided I want to go back to engineering, get the instant reward of deploying something or writing some code and being happy. Like the management side takes a long time to actually feel rewarded for what you are doing and trying to accomplish. So I came back to engineering, and I decided I need to look for something new to experience. I joined Apple for 1 year. I was on the service doc team. So Michael Nitchinger is currently working on that team, and I was interviewed by the Netty
Norman Maurer,
maintainer Norman. Such a privilege to work with these people.
So good.
And after that 1 year, I joined the Project Reactor team.
All right. So, and of course, Norman works on Netty, which is the project that Trustin Lee started, and we've had him on the show, Trustin, of course, and then Norman, he built a Swift equivalent to Netty as well, right, at Apple, as far as I remember, like a non-blocking I/O library.
I'm not aware of that, but I know a person who's working on the Swift team, Konrad. Yeah. Also from around here.
Yeah, but he lives in Japan.
He lives in Japan.
He's great. He's former TypeSafe
Yes.
Aka team,
So he
yeah.
has the Scala experience working with actors, and he's bringing all of that amazing, all of those amazing ideas to Swift.
Right. So maybe that's what I'm thinking of.
Yeah.
Never mind. I take it all back. I don't know.
I think Norman is primarily working on Netty and also some internal Netty usages.
Okay, maybe that's what I'm thinking of. I thought there was some sort of like, what's service talk?
So service talk is something in between like a framework and a library, because it offers you the things that you can use programmatically.
Yeah.
But it also has the means to work with those JAX-RS annotations to kind of run your service and discover the endpoints. But it's a networking, kind of inter-service networking layer that allows you to build servers and clients that can talk to each other.
Okay. Cool.
And it has security, it has gRPC, it has HTTP, and
okay, so maybe I'm thinking
it builds on top
like
of Netty.
I don't know. My brain is, it's too early in the morning or too early in the afternoon because I woke up really late because of jet lag. So okay, so then, so Apple's really doing really amazing things. I love what they're doing there. What's next?
So I joined the Project Reactor team, and I have been working with amazing people on the team, but not just Reactor. I have the pleasure to work with the Spring Framework folks, Spring Boot, and all the other portfolio projects, because Project Reactor is present in all of these projects. So we interact, and I had some time investigating performance in Spring Framework, and also the Spring AI is kind of the part where I'm currently
so that's
dedicating a lot of time to
for the MCP stuff, right?
For the MCP stuff.
So you did. I mean, the last time I saw you do work on you were working on the context propagation stuff in Reactor.
So that was one of the first topics that I actually got involved in, and this is an interesting story because when Spring Framework introduced the reactive paradigm to its portfolio by integrating the web client, which was replacing the async REST template.
Right.
That was a time that was quite difficult for us when I was at Allegro, because we actually recommended everyone to use async REST template because it allowed you to scale and not block the current thread.
Right.
But async REST template got deprecated, and a colleague of mine did a presentation where he compared the three approaches: REST template, async REST template, and the web client. And he said, like, sorry, but we will keep on using async REST template, which is deprecated, because web client has the problem of losing the context. And that problem has been really difficult for us because we were like, observability first. Everything needs to be visible on your Grafana dashboard, and we get pinged at night for things. So it was critical that the context propagation worked. And I never had the time to actually investigate the problem myself. I was concerned with other things, but we had people join our team and try to look at the context propagation problem in web client. And they discovered a lot of different recommendations. We also were considering Spring Cloud Sleuth, which solved that problem in some way, but we were we were not using the Spring Cloud part of the portfolio of Spring. We were just limiting ourselves to Spring Boot and the downstream. Downstream or upstream? I mean, so the libraries that Spring Boot integrates.
Right.
And the solutions never actually solved all the issues that we had. Like there were integrations that we had with the third-party libraries that suddenly started to lose the context.
Right.
And with async REST template, that was not the problem because you could restore the thread locals easily. And Reactor is a completely different beast. It has this notion of being thread agnostic,
right?
Which is a big obstacle in the way of propagating
Because everything was, we
thread
assumed the
locals
thread,
when you don't care about
threads.
threads, right?
Yeah.
It kind of switches threads as it goes along, but it's not easy to pinpoint where it actually happens. And
Right.
so I was fascinated by that problem. And when I joined the team, I actually saw this as quite an important thing to solve, because Spring Cloud Sleuth became the old thing, and the new thing was Micrometer,
Right.
which
The
had
tracing.
the tracing library as a separate artifact. And Spring Boot 3 adopted the observability with the observation
Right.
class.
Right.
And suddenly, reactive applications would have to actually propagate context properly. Otherwise, they would need to do the trick of restoring the thread locals every time something ran, and that's very, very costly.
Right.
So I tried to investigate what are the ways to solve that problem, and having now at the time some knowledge about how the reactive operators are actually running, what is the flow, I was able to figure out an idea that we can do this and that. And when we propagate down the stream, we can restore the thread locals. When we propagate back, we can get rid of them.
Right.
It's quite brittle, but there's a lot of code that I had to change. But finally, this thing works, and it's quite efficient, actually.
Nice.
So we had a few iterations. Actually, you mentioned Martin. We collaborated like every day on that, because like he had his changes in the micrometer side of things. There's the observation object which has things that are attached to it.
Right.
Handlers. I'm not sure what the term is,
Yeah.
but they're kind of the items that get notifications about a state change. Like you
Right.
enter a scope, you exit a scope,
Oh,
and that's
right,
where we
right.
need to
Like
restore some thread locals or launch a process such as reporting to our metrics backend and or log something. So that's where we need those thread locals to be present. And on the other hand, we had the reactor integration with that also had to be very tightly coupled with something that we extracted to another library called context propagation.
Yeah.
And context propagation is this thing that is quite agnostic. It has no dependencies. And it allows you to essentially instrument an executor service and make thread locals available, or capture them into a context object. And that's something that is central to those two pieces and allows you to build other things, not just like Reactor, but any kind of map can be captured into something that you can restore later.
That is super useful. Yeah, and so it's on top of that we built the micrometer stuff?
Yes, so Micrometer uses that, and essentially when you configure Micrometer with a Spring application to have tracing or logging, and all of those libraries need some implicit context.
Right.
It's undoable with passing arguments, because you, as a developer, you are not interacting with that third-party library. You just replace, Brave for
Right.
OTel, which is another instrumentation library, and you just expect this thing to work.
Yeah.
It will not work if it doesn't have thread local context present.
Right.
Yeah.
Oh.
So that's something that we as framework authors want to do for you, right? No.
Well, nicely done. Wow, that's so cool. That is the kind of stuff that just makes us the framework so much more valuable for people. Is this incredible, like these layers of richness that they don't have to worry about. It just works out of the box.
Yeah, that's the thing. Like, you never worry about the Wi-Fi unless it's not working, right? So we kind of need to provide a similar service as people expect, where they don't need to be bothered about the things that are quite hard to solve. Like Wi-Fi is an amazing technology, and a lot of people dedicated a lot of time to solve it, so that we don't have to think about it.
And of course, full circle here, I would argue that Wi-Fi wouldn't be here today if Apple hadn't shipped it in the iMacs. Do you hear that?
No, not really.
The first major consumer device to ever have Wi-Fi in the 90s was Apple. And Steve Jobs, terrorized a lot of people to make it happen, but it did happen, Like they didn't create it, but they made the manufacturing and distribution of it possible, at scale. and it became a thing that everybody could use. Do you remember they had the airport? It was they had the first major consumer Wi-Fi router.
I see.
It was also Apple. I mean, it's
not a user.
yeah, no problem. Okay, so now you've got like this incredible success in the reactive world, and then here we've got this new MCP client, right? The SDK and MCP is a new thing. It came out less than a year ago, actually in November of last year. How did you get involved there?
So I actually started collaborating with Christian Solov and Mark Polak on the reactive parts of the Spring AI
right,
API.
We do streaming.
So for streaming, all the large language models in use server-sent events to transmit the chunks of responses that they give you. And the team has decided like how to model that. Let's use a reactive Flux for that.
Yeah.
And now it became part of the API, but their experience with reactive programming was not that big, so they asked me for advice and for help solving some of the problems. So I started collaborating more and more with Christian. We managed to solve a few cases in Spring AI, and one day there's news about this thing called Model Context Protocol. At the same time, I was asking Christian all sorts of questions, and he was so helpful to explain how models work and how actually you can execute things that the model wants you to execute. And that's when he explained tools to me, and Model Context Protocol became this thing that people used to execute tools. But it's not just that. It's quite a rich
prompts and resources and all that. Yeah,
it's quite a rich protocol for making your application work with AI,
right?
In a very nice way that's decoupled and that's architecturally sound. And we started to integrate those concepts into Spring AI via a separate project, which we decided to ask whether Anthropic would like that to become the official Java SDK, and they accepted. We now maintain the official Java SDK.
Yeah.
But we have so many people coming in with issues, with pull requests, with ideas, and we are now in partnership with AWS, who are adding their code to things that are part of the SDK. Like we had really significant contributions for the streamable HTTP implementation, which is the current remote communications protocol
with tokens, right? Like the resumption and all that stuff.
So, yeah, there's like this idea of last event ID from server-sent events, by the way. So it's kind of something that was established long ago, but the streamable HTTP now allows you to build more advanced.
So you're not keeping a socket open. You can disconnect and resume somewhere else.
That's the idea.
Yeah.
And also there's a lot of people looking at this project, so it's very busy.
Yeah, very busy. I mean, goodness.
And Model Context Protocol itself is changing all the time. The new specifications are invalidating some things from the past, introducing new things, and it's constantly evolving. It's like the pace I've never seen in the industry before. But it's like very vibrant, and people are creating really interesting things with it. So very exciting.
It's very exciting. I mean, and this protocol, my goodness, it's from Spring AI. So Spring AI obviously repackages the MCP Java client and then provides autoconfig. So from there now, in the 1.1 release, we have these like @tool, MCP tool and MCP tool param and all that. It just, it's just a few annotations. You can have a working tool exposed as an MCP service in any method, any regular Spring Bean, just annotate them, and you're already doing as MCP, but that wouldn't work without what you're working on, which is so cool.
So what you are describing are very recent annotations that Christian added.
Before it was a method tool callback provider, and
he saw the need to express things that are MCP specific, because like the Spring AI had its own set of annotations, like @tool.
Yeah.
But as it kind of shows, when you build like really rich applications with MCP, you want to have a different kind of flow where so you mentioned the MCP client. There's like two parties involved in MCP. One is the client, which you can have many of those clients in your host application. That's the application that talks to the LLM. But there is also the part where you have a service provider. So for instance, you are the owner of a database of very interesting news articles that you would like people to take advantage of and get summaries on, but you don't want to be the one developing that software as a service thing. You just expose APIs, right? So you can now create an MCP server on top of that knowledge and expose it to someone using an LLM. So now the MCP client can connect to the server and they can talk to each other in quite interesting ways. So the MCP tool, for instance, can actually ask the LLM application to have some content generated creatively by the LLM, right?
So in the example, the news article provider doesn't have a model. It has access to its database of articles from the New York Times or whatever. Right. But it wants to provide a response, and it needs the help of an AI model to do that. So you're saying the service provider could ask the client to talk to its model.
Exactly.
Okay, so it's a push instead of a.
It's called sampling. It's that you sample the LLM for some more data that you might want to. The typical use case is summarization. For instance, you have a lot of articles, you select some of them, and you ask the LLM to summarize it, and then you can enrich the actual response to a tool call with that. I have no idea what people come up with because it's kind of a set of tools, and whatever you want to build, you are able to build it. There's another type of this rich interaction that you can have the service provider ask for more information from the user. So there's the client application that the user is interacting with. The server has no user in front of its API, so it can ask the caller, can you give me more data? Like, for instance, you were asking for articles and I found 1,000 of them, and I might want to limit that information and ask, hey, here are the categories of things, can you select some of them? So the application that the AI engineer has developed can now display a pop-up to the user saying, hey, we have so many articles for you. Do you want to focus on a particular category? And they can click, and that's called elicitation. So those are the more advanced schemes, but the simple ones, like...
So it's very conversational. It's bidirectional. It's like RSocket kind of.
It's an elaborate scheme, like you can imagine yourself sitting in front of the IDE or just a chat window, and you can have really like involving situations, and like security is the most important part of that. So every time like the Claude desktop asks you to do something, like do you want to share this with the LLM and stuff like that, the MCP servers should also ensure that they are given the permissions to act on behalf of the user on, for instance, a set of files or a set of documents that are in that database, right?
Amazing.
So this allows you to build really useful, but at the same time protected applications.
That is so cool. That is so cool. And so people can try out all this cool stuff in the 1.1 release. Is that true? That's not yet GA, but Spring AI. And it's already in the SDK. Is the SDK GA?
So SDK is not GA. It's still in 0 point. But as the protocol itself matures, we will be looking forward to stabilizing that. But at the moment, like the streamable HTTP is something that is from, I think, the previous generation from this one. But we recently implemented it, and I think we still have some gaps to fill. So I think the most important bits are those kind of long tail aspects, like we recently added the structured outputs and schemas. So I think once the protocol itself stabilizes, we can think of a GA.
Cool. I can't wait. I mean, this is going to be exciting. What are you most looking forward to?
In terms of MCP, Spring AI?
I mean, just I don't know, anything you want.
Oh,
Should
anything.
people? What should be?
I'm so excited about meeting people. Like I went to Devox, we met, and I met so many colleagues and people from the community. I'm meeting my gurus, and it's such a joy.
Oh yeah, amazing. Okay, are you on the as we wind down here? Are you on the internet? Do you want to be found, and if so, where can people find you?
Yeah, you can add my handle on Twitter or Blue Sky and LinkedIn. My first name, last name, but I am Chemical. So maybe we should type that in the notes.
So let me see what is.
Yeah, someone wants to follow.
Okay. So. Oh. Okay. Chemical, like that.
Without the A, and this thing is capital.
And what is this? Where is this?
Where is this? Twitter and Blue Sky.
Okay. YouTube. Okay. Do I need to do that? Let me see. No. Good. Okay. And then there's. Okay. Good. And then Blue Sky. What does that look like? What's the U?
I don't remember.
Blue Sky. Hey, I'll put it in the show notes.
Yes.
It's like I forget the root of it. All right. Well, this has been an amazing discussion, my friend. Dziękuję. Thank you very much.
Thank you for inviting me. It was a great pleasure.
To everybody else, have a wonderful, wonderful, what is it, Sunday? Yeah.
It is Sunday, yes.
Bye, everybody.
Take care.